Very good morning to all of you. Today I want to start session 8 of module 4. Title of module is given Bearing Capacity of Shallow Foundations. For this module 4, course outcome is finalized, that is ability to determine bearing capacity of soil and achieve proficiency in proportioning shallow isolated and combined footings for uniform bearing pressure. So this is the course outcome is given. Title of subject is Applied Geotechnical Engineering and the subject code is 18CV62 in 6 semesters of civil engineering departments. Okay, so here the subject is most important in foundation engineering concepts. Now let us see. In this session also there are so many problems are there to solve in terms of bearing capacity concepts. So last sessions also we have solved so many problems. So in this sessions is also required how different problems are asked with the different situations. Okay. Let us see today's first problems, that is example 4.11. A 2 meter into 2 meter footing is located at a depth of 1.5 meter from ground surface in sand. The shear parameters are C equal to 0 and phi equal to 36 degree. Determine ultimate bearing capacity of soil if first case water table is well below the foundation level, second case water table is at base of footing, third condition water table is at the ground surface. The unit weight of soil above water table is 18 kilonewton per cubic meter and saturated of soil is 20 kilonewton per cubic meter. Take NC equal to 50.5, NQ equal to 37.70, N gamma equal to 48.00. Let us see. So this is the problems. So here this problem is based on water tables, and based on these three conditions this problem is required to solve. Water table is at the base of the footing, water table is at the ground surface, water table is at the great depth. So based on these three case how problem is solved based on the given data. Solution. Given data, a size of footing is given 2 meter by 2 meter, depth of footing is given 1.5 meter, C is given 0, phi is given, that is 36 degree, unit weight of soil gamma is given 18 kilonewton per cubic meter, saturated unit weight is given 20 kilonewton per cubic meter, and bearing capacity factors NC equal to 50.5, NQ equal to 37.7, N gamma equal to 48.00. To find ultimate bearing capacity equal to how much? If water table is below the floor levels, second case ultimate bearing capacity equal to how much? if water table is at base of footing. Third condition, third case, QU ultimate bearing capacity equal to how much if water table at ground surface. So these three cases is asked to determine ultimate bearing capacity. Procedure. Solve first case. If the water table is below the ground level, below the foundation level, sorry, not ground level. If the water table is below the foundation level, that is, see this depth, this is the footing dimensions of depth of footing is 1.5 meter, width of footing is B is 2 meter, and saturated unit weight of foundation soil is given, that is 19 kilonewton per cubic meter, and this is ground level, and from here to here we are considering as a ZW21 equal to 1.5 meter, and B is nothing but a ZW2, and here we are locating water table, so from here to here DW is nothing but a great depths. Okay, so based on first case, after plotting the foundation diagram, calculate ultimate bearing capacity for square footing. Okay, but all of you remember here, plotting the diagram is important based on the water table situations, water table cases. Okay, so according to this diagrams, now you calculate ultimate bearing capacity QU for square footing is given by the following equation, that is QU is given 1.3 times CNC plus gamma DF NQ into RW1 plus 0.4 times gamma B N gamma into RW2. Now you calculate from the above equations RW1 and RW2, that is water reduction factors required to calculate by knowing the empirical equations. RW1 equal to 0.5 times 1 plus ZW1 by D. Now substitute the value here. 0.5 into 1 plus ZW1 is 1.5 meters divided by D is 1.5. We are getting answer is 1 for RW1. Calculate RW2 equal to 0.5 times 1 plus ZW2 by B. Now you substitute the value in this equation. 0.5 into 1 plus ZW2 is 2, B is 2. So answer is, after calculating, we are getting 1. Now substitute the value in the above equation, that is ultimate bearing capacity. 1.3 times C is 0, NC is 50 plus gamma is 18, DF is 1.5, N gamma NQ is 37.7 into RW1 is 1 plus 0.4 times gamma is 18, B is 2 meter, N gamma is 48, RW2 is 1. So after solving these parameters, answer we are getting 1709.10 kilonewton per meter square. This is the ultimate bearing capacity for water table at great depth. Second case, if the water table is at base of footing. Second case. Now draw the diagrams, that is foundation diagram. So now here this is the water table at the base of the footings. So then ZW1 is equal to 1.5 meter and ZW2 is 0. This is second case. This is depth of the footing 1.5 meter, width of footing B is 2 meter, and saturated unit weights 19 kilonewton per cubic meters. Now use the ultimate bearing capacity equation for square footing is given by the following equations, that is QU equal to 1.3 times CNC plus gamma df NQ into RW1 plus 0.4 times gamma B N gamma into RW2. So now you calculate water reduction factors RW1, RW2. So here RW1 is given 0.5 times 1 plus ZW1 by D. So here 0.5 into 1 plus ZW1 is 1.5 meter divided by D is 1.5. So now we are getting 1. Now calculate RW2 is given by the equation 0.5 times 1 plus ZW2 by B. So then substitute the value here. 0.5 times 1 plus ZW2 is 0 divided by B is 1.5. So answer 0.5, that is RW2. After calculating water reduction factor RW1 and RW2, now you substitute the value in the above equations, that is QU equal to 1.3 into C is 0 into NC is 50 plus gamma is 18 into DF is 1.5 into NQ is 37.7 into RW1 is 1 plus 0.4 into gamma is 18 into B is 2 meter into N gamma is 48 into RW2 is 0.5. So after calculating these values, we are getting 1401.90 kilonewton per meter square. This is the ultimate bearing capacity for square footing water table is at the base of the footings. So third case, if the water table is at ground surface. So now draw the diagram according to this third condition. So this is the footings, water table at the ground surface. See here, this is WT, water table at the ground surface. So depth of footing is 1.5 meter, width of footing is 2 meter, saturated unit weight is 19 kilonewton per cubic meters. So then now you calculate ultimate bearing capacity for square footing is given by the following equation. QU equal to 1.3 times CNC plus gamma DF NQ into RW1 plus 0.4 times gamma B N gamma into RW2. Now we calculate water reduction factors. RW1 equal to 0.5 times 1 plus ZW1 by D. So now substitute the value in these equations. 0.5 times 1 plus ZW1 is 0 here, divided by D is 1.5. So water reduction factor is 0.5 we are getting. Similarly, you calculate RW2. So substitute the value in these equations. 0.5 times 1 plus ZW2 is 0 divided by B is 1.5. So answer 0.5. After calculation of RW1 and RW2, now you substitute the value in the ultimate bearing capacity equations. That is 1.3 into C is 0 into NC is 50 plus gamma is 20 because submerged density. Okay, DF is 1.5 into NQ is 37.7 into RW1 is 0.5 plus 0.4 into gamma is 20 into B is 2 meter into N gamma is 48 into RW2 is 0.5. So after solving these value, we are getting the answer is 949.50 kilonewton per meter square. So this is the ultimate bearing capacity of this third case. So now you see what is the difference between these three conditions. If the water table at the ground surface 949.5 kilonewton per meter square, if the water table at the base of the footings 1401 kilonewton per meter square, if water table is at the great depth 1709, okay, 1709, 1400, 1949 means if the water table is decreasing, means towards the ground level SPC is decreased, that's ultimate bearing capacity is decreased. If the water table is increased from the ground surface, SPC value is nothing but ultimate bearing capacity is increased while seeing these three conditions. Okay. Example next, 12th. A strip footing 1 meter wide and a square footing 1 meter side are placed at a depth of 1 meter below the ground surface. The foundation soil has cohesion of 10 kPa, angle of friction of 26 degree and unit weight of 18 kilonewton per cubic meter. Taking bearing capacity factors from the following table, calculate the safe bearing capacity of soil using Terzaghi's theory. Use factor of safety of 3. These are the Terzaghi's bearing capacity factor is given in these tables. So based on the phi value, we should select the NC, NQ, N gamma value. Okay. Let us see solutions given data. Here width of the footing is 1 meter, that is strip footing, and square side 1 meter. Depth of foundation is given 1 meter. C is given 10 kPa, is nothing but a 10 kilonewton per meter square. Phi is given 26 degree and gamma is given 18 kilonewton per cubic meter. Factor of safety is given 3. Okay. Next, to find QS equal to how much for strip footing. In second case, QS equal to how much for square footing. Let us see in first case for strip footing how to plot the foundations sketch. See, this is the footing of depth DF is 1 meter, width is 1 meter, and unit weight of soil is 18 kilonewton per cubic meters. Now you follow the steps. Ultimate bearing capacity for square footing is given by the following equation. If phi is less than 20 degree, we are considering as a local shear failure. So that is QU equal to 2/3 C NC dash plus gamma DF NQ dash plus 0.5 times B gamma N gamma dash, where NC dash, comma N gamma dash and NQ dash values obtained from table above. Here select phi dash equal to 2/3 phi. So means 2/3 of 26 degree. So now we are getting 17.34 degree. With respect to this value from table, you select NC dash equal to 16.51, NQ dash equal to 5.8, N gamma dash equal to 4.3. So with respect to 17.34 degree. So from these tables, you select for 17.36 degree NC, NQ, N gamma. Okay. Therefore, substitute the value in these equations. 2/3 C NC dash plus gamma DF NQ dash plus 0.5 B gamma N gamma dash. In this equation, you substitute the value. 2/3 into C is 10 into NC dash is 16.51 plus gamma is 18 into DF is 1 into NQ dash is 5.8 plus 0.5 times B is 1 meter, gamma is 18 into N gamma dash is 4.3. So after solving this value, we are getting answer is 253.166 kilonewton per meter square. This is the ultimate bearing capacity. Then net ultimate bearing capacity is given by the following equations. Net ultimate bearing capacity equal to ultimate bearing capacity minus overburden pressure, that is gamma into dF. Now substitute the value here. QU is 253.166 minus gamma is 18 into depth of the footing dF is 1. So after calculation we are getting answer is 235.166 kilonewton per meter square. Then next you calculate net set bearing capacity, that is QNS, is given by the empirical equation. QNS equal to QNU by factor of safety, that is net ultimate bearing capacity divided by factor of safety. So now substitute in this equation. QNU is 235.166 divided by factor of safety is 3. So now we are getting the answer is 78.38 kilonewton per meter square. So don't forget units. Unit is also most important. Next step, safe bearing capacity is calculated by the following concept. QS equal to net safe bearing capacity plus overburden pressure, that is gamma into dF. Now in this equation substitute the value. QNS is 78.388 plus gamma is 18 into dF is 1. So after calculation of this we are getting the answer is 96.388 kilonewton per meter square. This is the solution of safe bearing capacity. Okay. Next, in second case for square footings. Okay, in second case for square footing. So draw the diagram, that is footing sketch. This is the ground level, this is the depth of the footing is 1 meter and width of the footing, that is side is 1 meter, and unit weight of soil gamma is 18 kilonewton per cubic meter. This is the foundation diagram as per the data. Now follow the same steps. Step 1. Ultimate bearing capacity for square footing is given by the following equations. If phi is less than 20 degree, considering as a local shear failure, that is QE equal to 2/3 C NC dash plus gamma dF NQ dash plus 0.4 times B gamma N gamma dash for local shear, where NC dash, NQ dash and N gamma dash values obtained from table above. That is select phi dash equal to 2/3 phi, means 2/3 of 26, we are getting 17.34 degree. With respect to this value from table, we are selecting NC dash equal to 16.51, NQ dash equal to 5.8 and N gamma dash equal to 4.3. That is with respect to 17.3, here 15 and 20 in between value is ours. So you select the value or interpolate. Okay. Next, substitute the value in ultimate bearing capacity equations, that is 2/3 into C is 10 into NC dash is 16.51 plus gamma is 18 into dF is 1 into NQ dash is 5.8 plus 0.4 times gamma is 18, B is 1 into N gamma dash is 4.3. So after calculation of these parameter, we are getting final answer 245.426 kilonewton per meter square. This is the ultimate bearing capacity. Next step, net ultimate bearing capacity is given by the following equations, that is net ultimate bearing capacity equal to ultimate bearing capacity minus overburden pressure. Now substitute value in these equations. QU is 245.426 minus gamma is 18 into dF is 1. After solving this, we are getting answer is 227.426 kilonewton per meter square. Then you calculate net safe bearing capacity. QNS is given by the equation net ultimate bearing capacity divided by factor of safety. Now substitute the value in this equation. QNU is 227.426 divided by factor of safety is 3. So we are getting 75.808 kilonewton per meter square. This is the net safe bearing capacity. Next step, you calculate safe bearing capacity. After calculation of net safe bearing capacity, now you calculate safe bearing capacity, that is QS equal to QNS plus overburden pressure, that is net safe bearing capacity plus overburden pressure, that is gamma into dF. So now substitute the value in this equation. QNS is 75.808 plus gamma is 18 into dF is 1. So now we are getting 93.808 kilonewton per meter square. This is the safe bearing capacity for square footing. For square footing is 93.8 kilonewton per meter square, and for strip footing is we are getting 96. So means if this shape of the footing is changed, bearing is also changed. That is the observations. Okay. See this problem. Next problems. How this problem is asked. That is problem number 4.13. A square footing placed at a depth of 1 meter is required to carry a load of 1000 kilonewton. Find the required size of footing given the following data. C is 10 kilonewton per meter square, phi is 38 degree, gamma is 19 kilonewton per cubic meter. For phi equal to 38 degree, Terzgy's bearing capacity factors are NC equal to 61.35, NQ equal to 48.93, N gamma equal to 74.0. Assume water table is at the base of footing. See, this problem is related to water tables. Okay. Now you solve these problems. Okay. Solution. Given data. Depth of footing is 1 meter. Load is given 1000 kilonewton. C is given 10 kilonewton per meter square. Phi is given 38 degree. Gamma is given 19 kilonewton per cubic meter. NC is given 61.35. NQ is given 48.93. N gamma is given 74.03. Assume factor of safety is 3. Okay. To find size of footing, that is B equal to how much? Procedure. Water table at base of footing. So then you draw the diagram. So this is the diagram. Okay. Depth of footing is 1 meter and width of footing is B, and saturated unit weight is 19 kilonewton per cubic meter is given, and water table at the base of the footing means water table is start here at the base, and then this distance ZW1 is 1 meter. Okay. After plotting details foundation diagram, now you follow the procedures. Ultimate bearing capacity for square footing is given by the following equations. For square footing, Q equal to 1.3 times C NC plus gamma dF NQ into RW1 plus 0.4 times gamma B and gamma RW2. In these equations, you calculate water reduction factors. RW1 is given 0.5 times 1 plus ZW1 by D. Now substitute the value. 0.5 times 1 plus ZW1 is 1 divided by D is 1. So answer is 1. RW2 is given by the relation 0.5 times 1 plus ZW2 by B. Here 0.5 times 1 plus ZW2 is 0 meter by B is 1.5. So answer is 0.5. Now substitute the value in the above equations, that is ultimate bearing capacity. 1.3 times C is 10, NC is 61.35 plus gamma is 19, DF is 1, NQ is 48.93, RW1 is 1 plus 0.4 into gamma is 19, B you write as usual. This is required. N gamma is 74.03, RW2 is 0.5. After solving this equation values, we are getting in terms of B, that is 1708.22 plus 281.31 B in kilonewton per meter square. Then next step, you calculate net ultimate bearing capacity is given by the following equations, that is net ultimate bearing capacity equal to ultimate bearing capacity minus overburden pressure. Substitute the value in these equations, that is Q U is this value minus gamma is 19 into DF is 1. So after calculations we are getting in terms of B in kilonewton per meter square, that is 1689.22 plus 281.31 times B in kilonewton per meter square. The next step, net shape bearing capacity, that is QNS is calculated by net ultimate bearing capacity divided by factor of safety. So now substitute the value here. QNU is 1689.22 plus 281.31 times b divided by factor of safety is 3. After solving, we are getting the values 563.03073 plus 93.77 times b in kilonewton per meter square. So next you calculate safe bearing capacity, that is QS is given by the relation QNS plus overburden pressure gamma TF. Now substitute the value in this equation. Net safe bearing capacity is 563.073 plus 93.77 times B plus gamma is 19 into DF is 1. So now we are getting the values in terms of B, that is 582.073 plus 93.77 times B in kilonewton per meter square. Then by solving we get B is 1.2 meters. Okay, so that is based on the above equations. By solving we are getting B is 1.2 meters. Okay, next problems. A strip footing 2 meter wide carries a load intensity of 400 kilonewton per meter square at a depth of 1.2 meter in sand. The gamma saturated of sand is 19.5 kilonewton per cubic meter and unit weight above water table is 16.8 kilonewton per cubic meter. Phi equal to 35 degree. Using Terzky's analysis, determine factor of safety with respect to shear failure for the following locations of water table. Take NQ equal to 41.4, N gamma equal to 42.4. First case, water table 4 meter below ground level. Second case, water table 1.2 meter below ground level. So this is similar to earlier problems. Okay, there are some values are changed, you can solve. So these are the references are referred for session 8 to covers. Okay, thank you one and all. Okay, next class I will be continue. Okay.